Good afternoon, everyone. Myself, Harshit Gupta from Indian Institute of Information Technology, Allahabad. So the topic which I will be presenting today, the optimizing federated learning statistical heterogeneity, a fire detection use case. So as we know that in the digital world or in the current era, the sensors are the most prominent component which collects the raw data from the systems, from the environment, from our mobile phones. And there are many application domains where these sensors are used, including temperature sensors, pressure sensors, motion sensors, etc. So these sensors collects data which are analyzed for the real-time monitoring of some processes or some conditions like some detection of unusual movement from the motion sensors, machine faults, the predictive maintenance of any system by using some vibration sensors, temperature sensors, and analyzing the data collected by these sensors. These tasks could be done. So as we know, there are millions of IoT devices in which the sensors are integrated for some specific kind of task. And these sensors continuously collects data for some specific set of applications. So when we collect the data from all for a proper analysis or for a comprehensive analysis of some set of application, it is required to collect the data from all these sensors and do analysis work by using some data-driven approach. So now when we talk about the approach of the data-driven approach, in the model, the terms of artificial intelligence comes into the pictures, which performs the predictive task very easy and very quickly by using the available machine learning or deep learning models, which makes the system to act intelligently. So to train such models, it is very much required that we should have a specific and sufficient amount of data for the training of the model. Like if we are going to predict the weather condition, then it is very much required that we should have a sufficient amount of data collected by these sensors from the different weather stations installed at different places in different environments. And these models trains to find out the trends, the hidden patterns, and makes the information informed decisions on the training of the model. So now the important part here, which needs to be see that in traditional machine learning approach, which we do normally, where the data are used to train a machine learning model, is required to be stored on a central server. So just like that, if we have integrated some sensors in industrial applications, and if we are going to make some specific set of applications like the predictive maintenance of the machines, then it is very much required to collect all the data to gather all the data collected by these sensors, which are installed at different geographical locations or the different industrial systems. But the important thing here is that the sensitivity of data, like if we take an example of the CCTV, like if it is installed at some inside the home, or if it is installed in some industrial area or in the place which is supposed to be a very sensitive place, and sharing of that data with some central entity in that case becomes a very risky. Similarly, if we take the example of health sector, the sharing of medical data, EHR data, the sharing of financial data, like if we are going to train a machine learning model for some fraud detection or for some for some offers to the customer based on their credit and their purchasing habits, it's very much required to have those data to be collected at a central place from the different users, which we can say the clients from the different devices. So sharing of such data leads to the issue of privacy. And also we have different laws in different countries, like the GDPR in Europe, DPDP in India, which resist the resistance to share the data across the countries. So keeping into consideration the issue of the data privacy, Google has introduced the concept of federated learning in the year 2016, which is also known as a privacy preserving machine learning. What the important thing behind this federated learning is it performs the training of a machine learning model without sharing the data. Means if we are going to train a model, it is not required to share the data of any person, any medical data, or the data collected by any sensor. Instead, the model, what happens in a traditional machine learning, the data is sent to the model, but here in federated learning, the model is sent near to the data. So the best example of this federated learning you can also see in your mobile phones, where a Gboard, which we generally use for the typing of anything in the chat, in the messages, whenever you will go the option of Gboard, you will find the option of privacy, where you can see the option, you can check, where you can see the option of delete learned word and data. So this is what the Google has introduced in 2016, that it has given its main application of Gboard, where the Google has trained a model from the millions of customers using their data which they used for the generally texting or for the chat applications. Now the important thing is how federated learning works, like how does the model is trained without sharing the data. So you can see the architecture of federated learning, where if we suppose that there are 4 clients in our system, and like 4 sensors which are collecting data at some places, which these sensors are collecting data, and each client has their own set of data. Now a centralized model is initialized at a server, and the same model is sent to all the participating clients for the model training. Once every model receives the centralized model, the common model, they start training their local model from their local data set. And once this local training of the model is completed, the model weights are shared with the central server, where they get aggregated by using some aggregation algorithms like the Fed average, which is the basic algorithm of federated learning, which was introduced by the Google initially. Now we have some more aggregation algorithms on the basis of different issues which occur during the training of our machine learning models. So now, as we know that the data is being collected by the different sensors, so there is a much possibility that the distribution of the data among these clients or among these devices will be different. So on the basis of the distribution of data among these different devices, it is categorized as IID and non-IID data, that is independent and identically distributed data. So here we can see in the image on the right side, the distribution of data among the 2 clients in IID manner and in NIID manner. Like if we see for the in IID manner, for the client 1, all the digits are given. Means if we have taken the example of the digit classification, the simple CIFAR10 data set, in which the classes from 0 to 9, every class is available to client 1, and similarly each and every classes is available to client 2. But if we see in the non-IID manner, there the only 0 and 4 classes are there for the client 1, and the 5 and 7 classes there for the client 2. So the distribution of the classes among the client is not a very much even, making the entire distribution non-IID. It has been observed that when the distribution of the data among the clients become non-IID, the performance of the global model deteriorates. Means on the IID distribution, we get the performance of the model as compared to the traditional machine learning model, or even better. But once we get the distribution non-IID, the performance of the model degrades. So we can see how. So we can see here in the client in federated learning, like if multiple clients have participated in the training process, their gradients are diverse from the main servers. Like we can see for the client 1, it is diverse away from the server, and similarly for the client 2. So to mitigate this issue, we have used stochastic recursive gradient algorithm instead of stochastic gradient descent, which is basically used in the federated learning. The stochastic gradient recursive algorithm, which is also known as the SARA, incorporates a recursive or memory-based component. It maintains a running average of past gradient and the current update, which is influenced by the current mini batch and the historical information. So by using this proposed approach, the recursive gradient algorithm, we have achieved the good performance as compared to the previously state-of-the-art method designed to deal with the statistical heterogeneity in the federated learning. So by using this proposed approach, we have also taken a use case for the fire and smoke detection, where we have taken a fire data set which is used to detect whether there is something fire is there or not. So we have taken this use case because in any critical infrastructure, sharing of data is very important, and this can be a very good solution to the privacy, and we have achieved the good performance by our proposed method in this use case. So these are the references. Thank you. So